So let's continue. So let us apply the open method now onto a problem. So we will try to solve the same problem that we solved from the bracketing method, no, the parachutist problem. So just a quick recap now. This is the solution from the bracketing method, no? So we have two sets of solution, one from the bisection method and the other one from the false position method. So then we find out the false position is much better, no, compared to the bisection method. Okay, let's try to solve this in open method. So first, uh, yeah, let's try to solve it in simple fixed point iteration. So I'll just copy the information here. So let's just modify this one. So this should be based on simple fixed point iteration. Okay, then we have the same governing equation because we have the same problem. Then for guesses, so we need one initial guess. So to be fair with uh, the bracketing method, so let's just employ these two guesses, no, in two different solutions. So employ two initial guess. Let's just say let's compare if we start with a larger and a smaller number, asa ta makakuha sa root with if the larger number uh, uh, converge easily to the root, then mas better ang larger number compared to the smaller value, no, of initial guess. So in simple fixed point iteration, so you need to modify first the equation so that you can have an iteration equation. So the equation is 9.8 times 68.1 all over C times 1 minus exponential of negative C times 68.1 close parenthesis minus 40. Since we are trying to solve the value of C, so we will equate this to 0. So now let us try to transform the value of 40 to uh, the right hand side. So this will become to be 9.8 times 68.1 all over C times 1 minus E, or exponential of negative C all over 68.1 times 10 is equals to positive 40. Then cross multiply in such a way that the remaining of the left hand side should be C, no? So that becomes C equals to uh uh man, that should become 40 times 9.8 times 68.1 times 1 minus exponential of negative C times 68.1 times 10, then close parenthesis. So you have now the modified equation. So let's just declare our iteration equation here. So your iteration equation ito na yung kopyahon. So ci plus 1 na nino. So let's just change the variable. So that is that is ci plus 1. That means your new root would be equals to 40 times 9.8 times 68.1 times the times 1 minus exponential of negative c divided by, or your ci, it should be ci, your present root divided by, no, divided by 68.1, then times 10, close parenthesis. That will be your new root. So let us apply the deciding iteration equation. To get the root. So this is simple fixed point iteration. So at least we need to have 2 tabs. So let's just say your ci. So this will be your ci. C sub I. Our initial guess here. So let's just go with the smaller value, which is 12. 12, no? So that would be, yeah, that would be equivalent to 40 times 9.8 times 68.1 times open parenthesis 1 minus exponential function for Excel exp, that is negative of the initial guess, yeah, divided by the 68.1 times 10. No? So close parenthesis, close parenthesis, siya. I think there's problem. Pinindako siya nun. It should be not. So, I think sayop ta dere, it should be divided by 40 di ay. Just, just let's just correct this one. So that should be divided by 40. So this one should be 1 over 40. Ito lang yung ituan para mas dali. So that is 1 over 40. Correct po din nato, that should be 1 divided by 40. Much better iya one. So first value is we get 3.8201. Then for second iteration, so we just need to correct the values, no? So drag this. Then we have 14.49. Then let's drag again. So let's try to get 14.77. So up until fourth iteration, let's just say we could have our error, no? Relative error value. So, yeah. Actually, the first iteration, okay na ang iyang acceptance error that is less than 10%. So, think we should go to the closer value, which is 40.77, no? Which is we could get in the fourth iteration. Then we copy this one. And let's try for a larger value, no? That is 16. So what did we get for based from the value 16? So same, kaupat. Then we get a closer value to the root. So I think there is no, since kwan magod na siya, no, kanang the idea is we know already the root, which is around 14.7. Even though mas closer ang katong higher value, we still get with we still kanang need to have iterations of 4 here. But anyway, the important here is we still get find the root based on the solution, no? Then you only need at least one initial guess. So then sure pa jud ka na ang katong initial guess kay will get you the exact root. So katong bracketing method, you still need to confirm that those initial guess is kanang okay na tanong. You still need to confirm it before you operate the execution of bisection or the false position. Okay? So how about in implementing the Newton-Raphson? So let's copy again this one. Change this. So based on Newton-Raphson. So our iteration equation will be based on a formula, no? Okay. So your new root here would be that would be c I plus 1, which is equals to uh the c sub I minus the fraction of f of c sub I all over the derivative of c sub I, f of c sub I. C. Okay. So your f of c sub I here should be, so let's create another equation. Should be basing on your governing equation, which is, yeah, 9.8 times 68.1 all over c sub I times 1 minus exponential function of c sub I divided by 68.1, no, times 10, then close parenthesis minus 40. So if we find now the derivative of c sub I, so saon man ni. So ato lang pod is simplify. So this would be, so f of c sub I, so before we derive this one, so yeah, so let's try to simplify this first. So that would be f of c sub I is equals to 9.8 times 68.1 all over c sub I minus 9.8 times 68.1 all over c sub I times exponential of negative ci all over 68.1 times 10, then minus 40. So the derivative of this would be the derivative of 9.8 times 68.1 all over c sub I minus the derivative of 9.8 times 68.1 times a exponential c sub I times 68.1 times 10 over c sub I minus the derivative of 40. So, simplifying this, so I think derivative of constant is 0. Then, this becomes ci negative 1, no? So, the derivative of this would be negative ci, then negative 2, exponent of negative 2, minus, you will apply, division rule, the derivative of the division rule. So, so take out the numerical coefficient. So that leaves you to this. So that is VDU minus UDV, no? Then C squared. So VDU CI times DU of exponential is E times C sa ato ni i-write kay baga rang kuan ink. So that is CI squared, that is VDU, so CI times E minus C sub I all over 68.1 times 10. Then the chain rule, which is negative 1 over negative 10 over 68.1. So ang imong derivative sa kaning exponent, then minus UDV, which is E raised to the power of negative C over 68.1 C sub I din times 10. No. Then derivative of B is 1 C sub I. So simplifying this, or pwede ra pod kanina lang, since you are just trying to employing the values, or we could rewrite this, pwede ra pod. That is 1 over C squared, C sub I squared, then minus, mas simplify ba ni? 9.8 times 68.1 times E raised to the power of negative C sub I all over 68.1 times 10. Times C sub I, that is minus 10 over 68.1 times C sub I minus 1 all over CI squared. So, mana ang simplification. So, you have the F equation of the derivative of FC sub I. Then, we could now create a table based on the iteration equation. So we will apply the iteration equation to get the root. So this is Newton-Raphson method. Kopyahan lang po nato ang tabs. Okay, so Our initial guess is 12. So first things first is delete. We need more columns here now. So we need to have yeah, your C sub I here is, I think, 12 sa. Yeah, 12. Then you need to have, before the C sub I, you need to get the value of the f of C sub I, and the the derivative of f of C sub I. So this is your first iteration. So this will become your 12. This is equals to 12 as your initial guess. Then we need to find your f of C sub I, which is equivalent to, yeah, the equation itself, that is equals to 9.8 times 68.1 divided by the C sub I, no? Dayon, close parenthesis, open parenthesis, 1 minus exponential function of negative of C, I don't know, the C sub I, yeah, divided by 68.1, close parenthesis, times 10, close parenthesis, then close parenthesis, minus 40. Okay. So let's recheck the equation if sakto ba. So that is 9.8, 68.1 divided by the C sub I times 1 minus E exponential, close parenthesis, minus 40. I think we're good. Then we proceed with the derivative, which is equivalent to 1 divided by the C sub I squared minus 9.8 times 68.1 times exponent of negative of C sub I divided by 68.1 times 10, close parenthesis, yeah, close parenthesis, then another close parenthesis times negative 10 divided by 68.1, close parenthesis, times C sub I minus 1, close parenthesis, and we create a parenthesis here for the division. Okay, so divided by C sub I squared, close parenthesis, close parenthesis, then I think we're good. Okay, so what do we need is to follow the formula based on Newton-Raphson. So that is your C sub I, minus the division, the quotient of your f of C sub I and the derivative of f of C sub I. So, ano? So, ning gamay ang value na to sa C sub I, which should not be.